Welcome to my online class. Welcome to Mr. Bam's online class. So today we want to talk about mathematics, and we have this question on the whiteboard marker. So find the derivative of the line joining these 2 points. We have to find the derivative of the line that's joining 2 points. So the first point is point A. You can see this point A, and second point is point B. You understand? So point A is having its pair of coordinates, the x and y coordinates. Then point B also is having its own x and y coordinates. So we have to find derivative, and the derivative is seen in calculus. In calculus topic, that's the topic we can see derivative. Why this topic is coordinates geometry. Coordinates geometry. This A and B, something like this, is coordinate geometry. Understand me now? It's found in coordinate geometry and also Euclidean geometry. It's found also in what? Euclidean geometry. You understand me now? So coordinate geometry deals with coordinates. Coordinates means like ordered pair. For example, x and y. You understand me now? In the rectangular coordinate system, we have x and y, x and y, x and y. You understand? It is called ordered pair. Ordered pair. You understand me now? That is, any point you have in your rectangular coordinate system is taken from x and y coordinates. You understand me now? So that's the coordinates geometry. So what we do here is that this is the first point, point A. You can call it x1, y1, x1, y1. So that's the first point. That's 1, 1. Now second point will be 2, 2. Understand? So that will be x2, and y2. So I can see my x1, y1 as 3 and 5, and my x2, y2 as 6 and minus 8. Hope you understand. So that's the coordinate geometry. And Euclidean is talking about shapes. You understand me now? Maybe straight line, triangle, polygons. You can see that this, the dimension line, that is a line is joining these 2 points. The first point is point A, and second point is the point B. So a line is joining it. So by the time we take the 2 points, the first point, let's say we have point A this way, this point A, you understand me now? And let's say we have point B this way, you understand me now? By the time we join the 2 points together, it gives us a straight line. So that straight line is this, the line joining the 2 points. The first point A, because A is having its coordinate 3 and 5, so we have the coordinates for A, 3 and 5 here. Then B is having 6 and minus 8. It's having its own coordinate 6 and minus 8. Hope you understand this. So what we are just doing here is that we are bringing the derivative, which is in calculus. We are bringing it into coordinate geometry and Euclidean geometry. You understand me now? So what do? You know, derivative is talking about dy dx in calculus. dy dx. That's your derivative. You understand me now? So you know, from this coordinate geometry and Euclidean geometry, there's this topic called gradients. Gradients. Understand now? Gradients M. Gradient or slope. You understand me now? So now let us look at it. How many points are we given here? We are given 2 points here, point A and point B. So you remember the formula for calculating the gradients of a line in 2-point form. 2 points. So that means the first point is point A, that's x1, y1. Second point is point B, that's x2, y2. So there's a formula for calculating the gradients in that 2-point form. So to get our gradients in 2-point form, just apply the formula that M, gradient M is equals to change in y over change in x. You understand me now? So change in y divided by what? Change in x. You understand me now? So that gradient is now your change in y means y2 minus y1. You understand me now? So over, and change in x also knows what? X means x2 minus x1. You understand me now? So that's our slope or gradient for straight line. So now this derivative actually means dy dx. You understand me now? Check them now. So divide the x. So what I'm going to do is that your slope, you understand me now? You make it to be your dy dx. Since changing y over changing x, you take it as dy dx. You understand what I mean now? Because this is it. Actually, you know, for every curve, you know that so for every curve, you understand what I mean now? So when you have a curve, let me put it this way for you to understand better. You know, whenever you have a curve, you understand me now? So at every point in that curve, eh, there's always a tangent. Tangent, that's a straight line that touches that point. For every point in that curve, for every point, there's always a tangent. That's a straight line that passes through. You can see the point. For every point on that curve, there's always a what? A tangent. You understand me now? So to get our dy dx for a curve now, you understand me now? That dy dx means that at any point we are given, you understand me now? That's tangent. You understand me now? That gradient of that line, you know, tangent is a line. That gradient is now that m. You understand me now? So for you to know the relationship between gradient, that's tangent, that line passing through, and your derivative that we have to find. So for every curve, the derivative at any point is dy dx. So at that point, that derivative becomes the gradient m of that line. The gradient of that line. So every line has gradient m, which is the same thing as the dy dx. That's the derivative of the curve at any given point. Yes, I mean now. So that makes you to know that that's our gradient m, which is change y by changing x, is same thing as dy dx, they are same thing. You understand what I mean now? So which means to get your derivative dy dx, just make it to be your m, and that is just apply this formula, and that's all. Just apply the formula and that's all. So let's see. So very easy and simple. So from the question, so easy. So find the derivative. So just say your derivative, that's the dy dx, which is going to be what? Y2 minus y1 over x2 minus x1. Just simply apply this formula and you are done. You understand me? So let's see. So y2 is what? Minus 8. So minus 8 minus y1 is what? 5. You can see over your s2 is what? 6 minus your x1 is what? That's 3. That's 3. You can see now. So we're going to have what? Minus 8 minus 5 is what? Minus 13 over 6 minus 3 is what? That is 3. So that's the answer. Minus 3 in 13 is 4 whole number 1 over 3. You can see. So that is your derivative of this, the line that will be joining those two, the 2 points. The answer is what? Minus 4 whole number 1 over 3. You can see. So easy and simple. So hope you understand it. So thank you so much. Once again, welcome to Mr. Bam's online class. So make sure you like, you comment, and then you share my video. Thank you so much. Remain blessed.